Okay, so it says, so you would select a group from that population, that's called a sample, and you'd study your sample. And ideally, what you observe in your sample, you can then generalize back to the population. Okay, and that's called inference. So what we have is, we've got a large group. This represents a population. From that population, we select a sample. Okay. And from the sample, we want to draw conclusions that can be generalized to the population. Okay, so from the sample, we hope our conclusions inference. Alright, so in order for our samples, in order for us to be able to generalize our conclusions back to the population, what must be true about our sample? The sample needs to be representative of the population. Okay, so samples must be representative of the population. If this is not the case, then we cannot generalize back to the population. Okay, so how do we get samples that are representative of our population? Well, there's another entire subfield of statistics that work towards getting samples that are representative of the population. Okay, and that's called sampling theory. Okay, or just sampling methods or sampling. Okay, so sampling is all about this, and one way that will give us, or that should give us a representative thing is called simple random sampling. Which is a simple concept, and it's just that from our population we select individuals at random to make our sample. Okay, we just randomly select individuals from the population. We randomly select individuals I should say one at a time from the population. And the key idea there is that everyone in the population has an equal chance of being selected. Okay, and that's simple random sampling. It's pretty straightforward and simple, generally, but practically, it's very difficult to do simple random sampling for any large group, for any large population. Okay, and the reason for this is that for everyone in the population to have an equal chance of being selected, we need to know who everyone in the population is. Okay, So simple random sampling requires what we call a sampling frame. Which is everyone in the population, or a list of, I should say, a list of everyone in the population. Okay. And all we do is we just randomly select from the sampling frame. It's very, very simple. The difficult thing is obtaining this sampling frame, okay? Obtaining a list of everyone in the population. So if your population is, if we just say people who live in the city of Los Angeles, can we get a sampling frame somehow? Census, maybe, okay? The closest we have is 2010 census, which will include people that no longer live in LA, and people, and doesn't include people who moved to LA since 2010. That might be the closest we have. But yeah, there's it's very difficult to get a list of everyone. Okay, and then the census, as hard as they try, will inevitably miss people without a permanent address. Okay, and or you know, just lots of people. Okay, so even our best attempts at getting a sampling frame, which is probably the census, is going to be inadequate. If you know our population was everyone who has autism, can we get a sampling frame? Yeah, very difficult. Okay, we can go across the country and ask who has who signed up for these government services and things like that, which might get us a pretty good idea, but inevitably we will miss people. Okay, so so practically, simple random sampling is actually very challenging to do because getting this sampling frame. Okay. However, so there's entire people who devote their lives to trying to improve sampling methods. It's difficult, but for the sake of study, a lot of our things will assume that our samples were obtained via simple random sampling. Okay, which is a bit of a dangerous assumption. Okay, but sometimes we have to make it. You just have to say these conclusions might not be valid because I'm assuming simple random sampling. That might not be the case. All right, but okay. So, but in our class, we will often assume simple random sampling. But that could be a dangerous assumption, or could be a bad assumption. And if if somebody gives you results from some study and it's clearly not simple random sampling, you can say, I don't believe these conclusions because it's clearly not a simple random sampling. Okay? Well, and a lot of times, or it's clearly not representative of the population, right? Because the idea is that our sample must be representative of the population. A lot of times in experiments, we ask for volunteers, and that's not going to be a simple random sample. We're just getting volunteers. But we could say, we have no reason to believe that our sample is not representative of the population. Okay? And a lot of times you have to do that with experiments. Okay? But if the sample you have is clearly not going to be representative of the population, then you have to be wary of that.
Miles?
Yes.
Why does simple random sampling has to be chosen? The population has to be chosen one at a time.
Because
in my mind, I'm thinking if I were to choose two people from this classroom, right? I'd say pick a number in your mind, and then if it matches my two numbers, then that'll be my selection. Won't that be random in that case?
It is random, but if we don't pick them one at a time, then the other part is that everyone has an equal chance of being selected. or
If I were to pick the same two numbers, regardless, if I I pick
yeah,
one first, one
I
second.
know what you're saying. The one at a time is important. Okay, so here's a random method, but it's not going to give me a representative sample. Okay, and let's say I need to pick a bunch of students all at once. Okay, so let's say this is my population, and I'm going to say this is how I'm going to pick my sample. I'm going to flip a coin, and if it ends up heads, all the males will be in my sample. And if it ends up tails, all the females will be in my sample. Okay, that's random. Everyone technically has an equal chance of being selected, things like that. But it's not going to give me a representative. Okay. So that one at a time is one of the ways to help us get a representative sample. That's like an extreme example, but that argument could be made anytime we're just picking two at a time or anything like that. So anyway, yeah, simple random, one at a time from a sampling frame should give us a representative sample. Okay, you have a few other methods mentioned in the book that I will leave to you in your reading, called stratified sampling and cluster sampling and all of that stuff. Okay, so you have to do your reading, and anytime we have sampling, okay, there's just an inherent thing called sampling error. Sampling error is not that we've made a mistake, but there's an inherent risk per se whenever we do sampling, in that every time we draw a random sample, we're not going to get exactly the same people. And so every time we draw a random sample, anything that we conclude from our sample will be slightly different from other samples. So let's say we just want to know, what percentage of the world is female? Okay, what percentage, or what percentage? This is a better question. What percentage of babies born are female? All right, let's say we if we go to we get data from hospitals on one day, we might find that 49% of babies born are female. Okay, and if we check another day, even if it's random sampling, we might find that 50% of babies born are female, or something like that. Okay, there's just, because of the nature of randomness, there's an inherent difference between samples, and that difference is sampling error. Okay, so inherent difference between random samples. And our study of probability and statistics will help us understand sampling error, which allows us to understand whether something could be a result of just random sampling error, or is it a result of the fact that things are actually different. Okay? That's what we must understand. Okay, let's see. Why don't we take a short break, and we'll take a 10-minute break, and then we'll come back and